Lakewood, it's Miss Hensley again. Today I want to talk about solving two-step equations. And the other day I was pulling out my jewelry to finish up this necklace, and I thought, what a great way for us to look at two-step equations. I look at my necklace and I have this really big bead that I like, and I really wanted it to be the centerpiece of my necklace. And I wanted to have nice balanced beads on either side. So I started placing my beads, and I started with the right side, and I just put a little pattern of 3, 2, 3, 2, 3, 2, and I used 15 beads to make my right side of my necklace. Then I started working on the left side, and I ran out of time, so I put some beads in the envelopes. I put the beads in 3 envelopes, and I know that I put the same number of beads in each one, but I can't remember how many beads are in each one. And then let's see if we can't use some algebra to figure this out. I put X's on my envelope because X is an unknown. I don't know how many beads are in each of those envelopes. But I know that if I wrote an equation, I could write an equation that looks like this. 3x plus 3 is equal to 15. I can see that 3 X's, or 3 envelopes, plus the 3 beads that I can see are equal to, it's my nice equal sign, a total of 15 beads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Great. So that's a nice picture, but how do I know how many are in each one? Well, first thing I'm going to do is I'm going to get rid of these 3 beads right here, because I can take these 3 beads off so that I want to get just the envelopes. But if I take these 3 beads off, I have to take 3 beads off of the other side. So I'm going to take these off and put them away because I don't need those anymore. Well, I can show that I took 3 beads away from each side. Now I have a new equation. This time I have 3 X's, or 3 envelopes, and now they're only equal to 12 because I had taken 3 away from these. Since I know that those 3 envelopes have 12 beads altogether. Well, the only thing I could think of, and the easiest thing I could think of, was then to start dividing these beads up. So I'm going to take all these beads out of this side. I still have my 12 beads, they're just mixed up a little bit. And I'm going to divide them up evenly between these X's. I'm going to say 1 for you, 1 for you, and 1 for you. I'm going to say another 1 for you, another 1 for you, and another 1 for you. And then I'm going to have another one, another one, another one, and yet another, just like I'm dividing and dealing out some cards to play Uno. So this now tells me that if I had these 12 beads and I split them up evenly between the 3 envelopes, that there should be 4 beads in each side. There's my divide by 3, and my prediction is that there should be 4 in each envelope. We can check by looking and seeing 1, 2, 3, 4. Let's put these. And 4. And 4. And sure enough, algebra helped me answer my question. I love playing with my beads and making jewelry, but that's not always practical when I'm in class teaching and learning. So I started thinking, what else could we do to remember how to use our inverse operations to solve a two-step equation? And I started thinking about getting my feet dressed in the morning before I come to school. What do I have to do first? Well, in the mornings, I have to put my socks on before I can put my shoes on. That's how we have to do it. Your socks have to go on before your shoes. Otherwise, you look crazy and your socks might get wet and very dirty. So then in the evening, if I'm going to undo or reverse this with my shoes, I'm going to reverse the putting the socks on and then the shoes on. I can't take my socks off until my shoes are off. And then I have to take my socks off. So in the morning, the socks go on, the shoes go on. When I undo that, the shoes come off and the socks come off. This is kind of like the order of operations and solving equations. This would be my order of operations right here. When I put things together, I say, well, I have to multiply and divide before I can add and subtract. So I guess my socks must be the multiply and divide, and my shoes must be the add and subtract. Then this is solving an equation with inverse operations. Well, of course, I have to take my shoes off first. So that's my adding and subtracting. Have to come off my equation first. And then I can finish up with multiplying and dividing. Let's look and see how this works. I can think about some order of operations. Let's zoom in a little bit. There we go. Let's think about some order of operations. And the example says that if I have the expression 4 times 20 plus 9, that if I am going to do the order of operations, I have to multiply first and then I'm going to add. My socks are multiplying and dividing. My shoes are adding and subtracting. There we go. I think that's better. Now let's focus. If I have another expression that says 20 divided by 5 minus 1, I know that in the order of operations, I have to do that division first. And then I can subtract. 6 plus 20 divided by 2, even though it comes second, I divide first, and then I add. And see if you can finish these up very quickly. Pause the video and complete this side. Welcome back. Here are the answers of the order to complete the operations if I were to simplify these expressions. Now let's look at solving the equation and undoing that equation. If I have an equation like 4x plus 9 is equal to 21, I remember that when I have my order of operations, I take my shoes off and then my socks off. So I'm going to think about what am I going to undo first. In this equation, at 4x plus 9 is equal to 21, I'm going to undo the addition first with subtracting. Thinking about the necklace, this is the same thing as taking 9 beads off of both sides. The 9 that I can see, and then to keep it balanced, 9 from this side. Then I would be left with 4 x's. So then I'm going to undo multiplication with division. It's exactly the opposite of what I would do with the order of operations. This problem says x divided by 5 minus 1 is equal to 4. This time I have a minus 1, or subtract 4. So I'm going to undo subtraction with addition. And then I have my division. I'm going to undo the division with multiplication. Another example with a fraction, but we know that fraction is just a division sign. So I got to get rid of that 6 hanging out there by itself. I'm going to undo addition with its inverse operation of subtraction. And then I'm going to undo the division with its inverse, multiplication. See if you can finish this sheet. Pause the video and then come back to check your answers. Okay, here are the answers. Check to see that you have your answers correct. Pause the video and check back in when you're finished. Great. Now if you'll turn the page over, we can practice solving some two-step equations. While we're solving, we can think about either figuring out the mystery number of beads on the necklace, or we can think about taking our shoes off before we take our socks off. When we solve two-step equations, it is very important to use the correct form. So on this equation, x divided by 6 minus 5 is equal to 7. We know that we have to undo the subtraction with addition first. So I'm going to show that I added 5 to both sides. Well, these 5 leave things at 0, and I have x over 6 is equal to 12. Then I know that I have to undo the division with multiplication. I can multiply both sides by 6, and the solution is x is equal to 72. Don't forget to check your work. Substitute your value of x into the equation. So now instead of x, I'm writing the 72. 72 divided by 6 minus 5 is equal to 7. The order of operations tells me I have to simplify that division first. And when I do that, I get 12. I bring the 5 down, I bring my 7 down, I do my next step, and I get 7 is equal to 7. Let's try another one. In this equation, x over 5 minus 1 is equal to 4. I know that my first step is to undo addition or subtraction with its inverse. Minus 1, the inverse of subtraction is addition. I'm going to add 1 to both sides. It is important for you to show this step. I'm going to cross that out because that leaves me with 0. I am left with x divided by 5 is equal to 5. I think, what number when I divide it by 5 gives me 5? I have a divide by 5. The inverse of divide by 5 is multiply times 5. Those 5's cancel out. But if I multiply this side by 5, then I must multiply this side by 5. Now the x is alone, and it is equal to 25. Let's check our work. I'm going to substitute the value of 25 for x. 25 over 5 minus 1 is equal to 4. I know that 25 divided by 5 is 5. Minus 1 is equal to 4. 5 minus 1 is 4, and 4 is equal to 4. We are correct. Let's try one last example. Think of yet another story. X is at a party, X is at home, has some friends and family over, and gets tired and wants to be alone. That means we want to be isolated. The x wants to be isolated. So x says, okay, too many people, some of you have to go. Well, I'm thinking that x is going to get rid of the people and kick out the people that it's not as close to. And when I look at this, the x is very close to 2, but isn't as close to the 6. So the 6 has to go first. I see that this is a plus 6, so I use the inverse, minus 6. I'm going to do that on both sides. That goes away. X divided by 2 is equal to 12. X still feels like there are too many people around, so we're going to tell the divide by 2 to get out. To undo division, we multiply. There's my inverse. I must multiply that side by 2 as well. Those 2's go away. X is equal to 24. One last check. 6 plus 24 over 2 is equal to 18. Well, 24 divided by 2 is 12. I put my plus 6 back on. 18 is equal to 18, and it is correct. Those are all using division. What if I have some that start as a multiplication? No problem. I'm going to do it exactly the same way. I am going to get rid of, I have 8 plus 3x equals 29. The x wants to be isolated. I'm going to undo the 8 and get rid of the plus 8 first. Minus 8 goes away. 3x is equal to 21. Now I have multiplication. I undo multiplication with division. There's my divide by 3. There's a divide by 3. Those go away. X is equal to 7. Let's check it out. 8 plus 3 times 7 is equal to 29. Well, order of operations says I have to do the multiplication first. So now I have 8 plus 21 is equal to 29. I can put those together, and 29 is in fact equal to 29, and I did it correctly. Pause the video again and complete these 3 examples, then come back and check your work. Here are the solutions to these equations. If you need more practice, there will be practice near the controls. And if you have questions, as always, please feel free to ask your teachers.